All right, so here we're moving from the or probabilities of events that are mutually exclusive to the ones that are not mutually exclusive. So the not here is the key on this one. So now let's consider the deck of 52 cards we have here on the right side. And suppose that these cards are shuffled and you randomly select one card from the deck. What is the probability of selecting a diamond or a picture card? Basically a jack, a queen, or a king. So again, these over here are picture cards, Jack, King, and Queen. And if we add the individual probabilities together, the sum is not going to be the probability of selecting a diamond or a picture card. The problem is there are going to be three cards that are simultaneously diamonds and picture cards. And we can see that here because we have a Jack of diamonds, we have a Queen of diamonds, and we have a King of diamonds. Okay. And so if we look at all the diamonds together and we look at all the face cards together, what happens is right here in this middle piece, there are three that are both diamonds and face cards. And so that becomes a problem because that means we're doubly counting these cards. And so the events of selecting a diamond and selecting a picture card are not mutually exclusive because they can occur together. And so it's possible to select cards that are both a diamond and a picture card. And so that gives us something that we're going to have to take care of in the next type of probability. And so the Venn diagram showed that three of the cards, the three diamonds and picture cards are together counted twice when we add the individual probabilities, like I said before. Now, the first three cards get counted as diamonds, and then they get counted as picture cards. So in order to avoid that error of counting them twice, we need to subtract off the probability of getting the diamond and the picture card together. So the probability of a diamond or a picture card is going to be the probability of a diamond, and a number of those, well, there's 13 out of 52 plus the probability of a picture card. Well, there's 12 of those. There's three picture cards times four suits, so that's going to be 12. So that's going to be 12 out of 52. And then we're going to subtract off the ones that are the same. And remember, those were the ones that were in the middle here that were the same. There are three of those. And so we're going to subtract off 3 out of 52 here. So basically, we're taking 13 plus 12, then subtracting 3 on the top, all over the same denominator. If we had different denominators, then we'd have to do something different. But since they're all the same denominator, we subtract that, we get 22 out of 52, and we can reduce that to 11 out of 26. And again, we can do that on our calculator really nicely, and we can look at that here in a little bit. So in general, if A and B are events that are not mutually exclusive, the probability that A or B will occur is determined by adding the individual probabilities, and then we subtract off the probability that they do occur simultaneously. In this case, that, you know, three of them, the king, the queen, and the jack, that are also diamonds. Okay, so that's what we're going to look at. Now, or probabilities with events that are not mutually exclusive. So this is what it looks like equation form. So if A and B are not mutually exclusive, then the probability of A or B is the probability of A plus the probability of B minus the probability of the A and B. Now, in set notation, that looks like the probability of A union B, A being the or is the union, is going to be the probability A plus the probability of B minus the probability of A and B. The upside down U is what and is equal to. Okay, so that's how it's going to look. So in our example here, in a group of 50 students, 23 take math, 11 take psychology, and 7 take both math and psychology. Now, if one student is selected at random, find the probability that the student takes math or psychology. All right, so we want the probability of math or psychology. Well, that's going to be, well, guess what? Since there's something that they take both of them, that means it's not mutually exclusive. So we're going to find the probability of math plus the probability of psychology. And then we're going to subtract off the probability of math and psychology. Okay. Well, what's the probability of math? Well, how many take math? Well, 23 take math out of the total. Well, 23 plus 11 and so that's going to be 23 out of 50. Now, 11 take psychology, so 11 out of 50. And how many take both of them? Well, that's going to subtract off 7 out of 50. So now we have 23 plus 11 minus 7. So that looks like it's going to be what? 27 out of 50. And again, the best way to represent this as is a fraction, and so I'm going to leave it as a fraction. If you wanted to do a decimal, you're not going to have an exact number, and so that would be a thing you need to find out what your question actually asks. In this one case, it doesn't say, so I'm going to leave it as the fraction. All right, let's stop there, and we'll come back for more.